We're going to sort by number, by text, and blanks. As we wheel down through this, you can see on the surface, it looks simple, but there's some pieces we need to put together in order to pull this off. Down here, I explain what we're trying to do. Over here in the narrative, a very long write-up in order to pull this off. 4 different answers to the what if. One of a kind, the sort, the order. Some of the tools, we have the sum and the frequency. We have the count blank, if, rows, index, match, min, if, is number, and match. How about if and row and the mult function and transpose and rows? This is of interest. Stay tuned. This will be fun. Brad Williams, Excel Prime, sort by number, text, and blanks. This is going to be the Swiss Army knife of sorting. We have text, we have numbers, we have blanks, we have duplicates, we have priorities. In the end, we're going to sort this thing. You're going to see here, we're going to sort by number, by text, and by blank. This thing is comprehensive. I'm going to read because you can see this entails a lot of work. And I'm going to just start from the beginning and walk us through this thing to actively sort and extract unique values from a list of data. You can use a list formula to establish rank in an assist column. We're going to have 2 assist columns here. We're going to have 2 name ranges. We have miscellaneous 959, which is going to be this information here, sort of a quasi-array. And then we have order. Order is just an ancillary data. If the arrows are bothering you, well, that's a function of this protect sheet deal. And I unprotected the sheet. All I have to do is hit protect sheet, get rid of it. Here is our formula. We're going to have 3 different formulas. We've got a formula here. We have a formula here. And then our ultimate sort is right here. So here is if B513 is equal to blank. If we look in here, we're going to have an if. So we have an if and then value of true and then value of false. Basically, we're throwing a whole bunch of kitchen sink stuff to fix this thing or to solve this problem. I just mentioned the name ranges. Here are talking points. In an assist column, the mult function is used to compute a numeric rank. A numeric rank here, somewhere in here. As an option, you can use this mult function to compute a numeric rank, which is then used by an index and match formula in G to extract unique values. Over here, we have this mult. Basically, I'll explain it to you shortly. The mult function performs matrix multiplication and assigns each value with a numeric rank. The expression below produces the initial list. B5, B13, transpose B5, B13. The transpose function is used to create a horizontal data list, and all values are compared to one another. Essentially, each value is compared to each other in order to answer the question, is this value greater than every other value? This yields a list containing true and false values with 9 columns and 9 rows. The double negative is used to force the true and false values to be 1 and 0. Return the previous mentioned matrix of 1 and 0s is transformed into list 1 by the mult function. List 2 is created using the following expression. You see this B5, B13? Then we have this exponent of 0. Here, each row number in the data is raised to the 0 power to create a list, 1 column by 9 rows, containing the number 1. Mult then returns the matrix product of the 2 lists, whose values are displayed in the rank column. We receive all 9 rankings all at the same time in a list, so we must enter the results into separate cells all at the same time. Otherwise, each cell will only display the first ranking value from the return list. This is a multi-cell list formula that requires Control-Shift-Enter, with the exception of Excel 365 in 2021. Blanks. This part of the formula deals with empty cells. If B5 to B13 is equal to blank, rows B5, B13. Before dealing with mmult, we determine whether the current cell in the data is empty. If so, a rank value equal to the total number of rows in the data is assigned. This is done in order to force blank cells to the bottom of the list, where they can be easily removed as unique. Counting. Here's the formula for counting unique values. Sum, then we're going to put frequency in C5, C13, C5 greater than 0 minus E8 greater than 0. Since the ranking formula above assigns a numeric rank to each value, we can use frequency with sum to count unique values. If there are empty cells in the input data, we then subtract 1 from the results, E8 minus 0. And it contains the formula count blank miss959. If there are blank cells in the data, we reduce the unique count by 1, as these are not included in the result. The index and match formulas use the unique count in cell E5, which is labeled unique, to filter out blank cells. To remove unique values, we're going to use this formula, which is basically is right here. It's going to be this. From there, before running the index and match formula, we first determine whether the current row count in the extraction area is greater than the unique count in E5. If rows G5, and this is going to be expanding, is greater than E5 blank. If this is the case, we are finished removing unique values and return an empty cell. Otherwise, we apply this formula, index, miss, match, and then we're going to have this multiple match. Two match functions are contained within one another. The inner match employs an expanding list and the name range miss959 as the lookup value. Right here. Here's our internal. Match, miss. In this example, the expanding list begins in the row above row 5. For each value in miss959, the result of the inner match is a list containing either a numeric position or the NAR, suggesting that the value has not yet been removed. Then, using if and is NA is not available or is an NAR, we filter these results and return the rank in value for all unextracted data. Then, using if and is NA, we filter these results and return value for all unextracted data values. If NA match miscellaneous, this is the outer match. This operation produces a list that is passed to the min function to find the minimum rank value for data values that have not been removed. The min function returns these values a lookup value to the outer match in the name range order 95 as the list match min extracted. Finally, match returns the row number relating to the position of the lowest rank value to index. An index function returns the data value in the current row of the extraction list. Yeah, I told you it was the Swiss Army knife, and it is a lot of work, okay? So here we go. Here's our extraction. If B5, all right, we're going to do the logical test. Value of true, value of false. Basically, we're doing a quasi-rank. What we're looking at here is, well, you see this number, and you see this number, and you see this. We have some uniqueness here, or non-unique. We're just counting, well, we're counting dupes and everything. So if B5 is equal blank, do this value of true. Row B5, B13, F9, and that's going to give us 9. Right. Okay, it's counting. Counting this right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. B5, B13 says if there are any blanks, count them. Otherwise, go over to mmult. Otherwise, if true, if false, go over here. F9, escape, F9. Now, notice if we go here, F9, we have 9, all right? Are there any blanks? No. And then value of true, F9, is here it is, 32038. And what's it doing? you can see what mmult is doing. It's going down and basically identifying any arrays and then multiplying together. What's the first array? We have this B5, B13 greater than transpose B5, B13. What the heck are you talking about? See, there you go. You have this deal and you're going to transpose this stuff. Transpose this, and then you're going to do what? You're going to multiply it by this count, which is going to be 1. We're looking at this thing. Pretend this isn't here, but this is exactly what it's doing. You see this 320? Okay, 1,000. That's going to be right here. Then we're going to have 33 sheep. Then we're going to have Ford. And then we're going to see, you're going to see their duplicates here. Swimming, so on and so forth. This is what the transpose is doing. This is sort of our assist. We can throw it over in here. Instead of doing all of this inside this sort function, we're going to reference this assist column. Do you get this? We have this mmult, F9. If we look at the array again, F9, you see what we're doing here? We're going to have 0, 1. Okay, let me try to define this mmult. Looking here, we have this mmult, and it breaks down to this right here. We have this B5. Sorry, I have to do it this way because I have to explain how this works. Mmult, we have this B5, B13 greater than transpose B5, B13. What the heck does that mean? It means what we're doing is, here is B5 to B13, orange. We have this orange Texas. Then we have orange Texas or orange. And I don't want to recalculate this thing, so I'm trying to be very careful here. We have this particular array. And the question is, we have to compare, is this greater than this? And because we set up the transpose and because it's an mmult, what we're doing is we're going to take orange. We're going to say, is orange greater than orange? Yes or no? Then we're going to go, is orange, because we have this matrix multiplier, we're going to go and check every one of these. Here's what it looks like. This is, right here, this is mmult. You see this B5, B13? This is B5 to B13, right here. So see, I need to be really careful here. See that? I was afraid of that. In short, here's B5, here's the transpose B5, B13. Here is B5, B13 greater than transpose B5, B13. Here's the multiplier. All we're doing is taking rows, which are going to be 1, because we're taking each row number, which is going to be 1 through 10 or 9, and the exponent is 1. That's not the issue here. What we're trying to do is figure out this mmult. And in short, what we're doing, as I just showed, was we're taking this B5, B13, F9, which is going to be orange, and based on the M multiplier, we take the transpose, B5, B13, F9. Here's what it looks like, without me screwing it up again. We have orange. Look at orange. We have Texas. We have OR. We have orange. We have Windows. We have Ford. We have a blank. We have Windows. We have 1, 2, 3. So basically, we're going orange, orange. False. Is orange greater than, and here it is. See, it's greater than? We have orange greater than orange. No. Then we have orange greater than Texas. Yes. Is orange greater than OR? No. Is orange greater than orange? No. But is orange greater than Windows? Yes. Is orange greater than, there's a space in here somewhere. Is orange greater than Ford? No. False. Is orange greater than the blank here? No. False. Is orange greater than Windows? Yes. Is orange greater than 1, 2, 3? No. And we go through, and is Texas greater than orange? No. No. Is Texas greater than itself? No. The only true we get in Texas is greater than Windows. Then, you see the complexity here? In the end, we're going to get this priority, okay? It's going to smush all this stuff together, and it's going to prioritize everything here. Hit escape. And you can see if we go down to 1, 2, 3 windows, 1, 2, 3 windows, we're going to see 1, 2, 3. We're going to see, you see 1 is greater than 1, 2, 3 greater than orange. Yes. Is it greater than Texas? Yes. Is it greater than OR? Yeah. And basically, we're going to filter this stuff, okay? So basically, we're saying multiply. Then what happens is this outcome here, all of this is multiplied by this, by ones. And ultimately, this is what we get. You see here, false, 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 true, true, true. These are just numbers. In the end, mmult is going to rank these. It's going to give us the outcome. And ultimately, in the end, we're going to see all this right here. And it's going to multiply by this second array, F9. See, I said it was all ones. In the end, it says if B5 is equals blank, there's no blank. Oh yeah, there's row B5, B13, otherwise mmult. The final outcome of this thing is this order. It's just an order. And believe it or not, this is just an assist. Over here, one of a kind, sum, frequency. Here we have sum. We're going to add up something. Frequency, C5, C13. What's frequency? Our data array. Go here, frequency, our data array, which is C5, C13. And our bins, C5, C13. It's saying greater than 0. Look here. If we look at this thing, data array F9 is going to be 6. Our frequency, and then our bins array F9 is going to be 46379. All right, so it's looking at this C. It's looking at one of a kind. It's looking here to determine how many unique there are. You see there's multiple 4s. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's one of a kind. Why? Well, look, 4, 4, duplicate. Keep in mind, one of a kind, we're not including the 7s or the 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9, and we come up with 6. Come up with 6 because we have to take account the blank cells here. Probably should address the blank cells first and foremost. All we're doing is counting blanks. We have 1. We're looking at miss, 9 finds. All we're doing looking here is 1. So one of a kind is 6. Wow. Now, the meat and potatoes. What are we doing here? If rows G5 to G5. Okay, now we have to work through this. Our goal here is to sort this. Where we have to first look is to make sure that we're only grabbing 6 bits of data. We want unique. So here's our unique right here. We have to test this first and foremost. Rows G5, G5. Notice the absolute value. If it's greater than, let's go back here. Our logical test. We have to pass this first and foremost. Value of true. Okay, we don't want true. And then value of false. Let's get through the first part. We passed the first test. G5, that means ourself. Is this greater than E5? Basically saying, if we're greater than this, we need to go blank. That means we're trying to find something that's not unique. Simple enough? Okay, and then this expands down. Notice now it goes down to G6. Saying G5 to G6, are we greater than E5? Are we greater than here? No. Now, we have to find number 1 here. Then number 2, or whatever the next rank is, okay? So we're going to go 1, 2, 3, which should be the highest priority or the lowest number, Then we want Ford. And again, we're using numbers as the lowest, and then alphabetically, and then blanks as the last input, all right? And here's our blank. We're going to use this, we're going to have to cross back and forth. So here we have the index. And the index is our array, which is going to be B5 to B13. Then our row number. Well, this is our row number. And we have to kind of just, we're going to have this internal, and then we have the external match. Well, let's go to match 1. Match here, and then we have match here. Remember, if we go to match, first and foremost, go back and look at this thing. We have this match. We have our row. This is our row number. We know if we go in here, what's our lookup value? It's going to be this big old min if. Pretty ugly, isn't it? Because we have this big old min, and then we have this lookup array. Notice index is using the data, but how are we going to find the row? Well, we got to use the numbers. Here, our lookup array is going to be C5, C13. But our lookup value is this really nasty looking thing. Let's see if we can find out what's going on here, our lookup value. But then we have this other. Well, now we have to go back into this internal, and we have to go, oh my goodness. So now we got to go back into B and look up G4 to G5. G4 to G5. Okay, breaking this thing down. Here, we're going to go back in, and I'm going to use number 4. 1, 2, 3, 4. I'm going to use OR right here, just because I have a display here. What I did was I broke this thing down. From this match, I want to break this match down to its lowest common denominator. What I did is I took match right here. Okay, I took match, and I went across, and I broke this thing down to min, to is NA, to its lowest common denominator, okay? So here, if we look at this formula here, look all the way to the right, we're going to have match. Remember what we're trying to do. We're trying to parse this thing, see what is in B5. We're trying to match. We're trying to match this to whatever this output is here, to here specifically. We have to go row by row. All right, so this is the output here. Here's match. If you take this, the match from here, this is what it looks like. It's right here. This is match B5, G4. This is what it looks like, okay? If we break this down, this is what it looks like. Match B5, B5 to B13, and then we're looking G4 to G8. We're going to match. We're going to match this, okay? And this is how it works. We're going to go 1,000. 1,000 is what row here? It's going to be 2. Now keep in mind here, this section here, and it would be this match, MIS 959, G4 to G8. This section here, this sort here, this is the G4 to G8. G4 to G8. So this basically tells us 1, 2, 3, 4, 5. That means the maximum number that we can have in this evaluation is 5. We can't match anything more than 5 characters in this particular test. When we go through here, that means max 5 rows. So we have 1,000 is 2. We're going to go Okay, 1,000, 1,000, 1,000, 1, 2. Then, does flour show up anywhere? Flour. Is it in our list? Is flour in G4 to G8? Well, look, flour, 1, 2, 3, 4. 1, 2, 3, 4. Then we have flour over here. We do it again. Then we go OR. Is OR in here? That would be 5. Why? Because it's in this list here. 1, 2, 3. Sort. Sort is just, we have to start at 0, okay, in order to pull this off. And so this is just this is brute force. Go down. Is orange in our list? It's in this list, but it's not in our match list. And then keep going, 3, all right. Is swimming in 1A? No. Is 1, 2, 3? Yeah, 1, 2, 3. There it is. Then is Windows? No. That's why we're getting these NAs. So basically what we're searching for in the end is the next NA. So we need 6. It would be 1, 2, 3, 4, 5. 5, well, okay. This number here is ultimately going to be our next requirement. But because we haven't found it yet, again, we're doing this, we're sorting this by unique and by priority. One, we're looking at our numbers, and then we're prioritizing them. I know this one is really challenging. Okay, we've sorted through our requirements here. So our next test is this is NA. Match. All we're asking is, are there any is NAs in here? Be sure to check out our extensive courses, which include Excel data and text manipulation for advanced users, beginners, intermediate. We also have this great essentials, the A to Z for advanced users, the comprehensive beginner level 1 and 2. Then we have our advanced formulas, strictly formulas, great set of courses, which we have a beginner level 1 and beginner level 2, this intermediate level, and we have this advanced level. Click on any of the links. There's a short video that explains everything about the course. Check it out. All we're doing is attaching this to match. So no, 2 is not NA. False. No. Yes, true. So what's this saying? We need to turn this NA into true. And then we need to find, all right, our next step, moving from this formula, we just went from, you see this right here, we have if, see this, we went through the is NA, so this is the is NA part of it. So now we're going to have this if is NA, if true, logical test, value of true. Now what do we have here? We have these trues. Then we have to go C5 to C13. C5 to C13. If true, find the NAs. What do we have here? We have 6, 7, and 8. Notice we have 2, 3, 4, 5. If you parse this is going to be 2, this is going to be 3, this is going to be 4 in terms of priority. So now we have this if is NA. Then again, remember, we're just focusing on this cell right here, this one right here. Then we go to min. We're going to look at this list here, and we're going to say we need number 6. We need number 6 right here in our order. Then we go here, and our match ultimately says match is just the row number. Match is going to be 1, 2, 3, 4, 5. Holy camole, are you kidding me? So now we go back in here. And we test this thing. Rows, did we pass this? Yes. Then we go here. We have this if statement, logical, value of true, value of false. F9. F9, and we have OR, and maybe I was talking about orange. Here, 1, 2, what is that? 1, 2, 3, 4. If you break this down, go here, because you remember I was looking here, G4, G8, which is right here, which is orange. G4, G8. I know this one's tough. You're going to have to spend a little time picking through this thing. But in the end, this is the row, okay? We're going to do this logical test, value of true, value of false. And it's going to say orange, all right? And if you look at this thing, see, if we look here, we're going to look at match, and we're going to look up our min, F9. We have 6, row 6, where our lookup array? F9, 1, 2, 3, 4, 5. And where is 5? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You know, I encourage you to tear this thing apart. This is probably the most complex, one of the most complex I put together. Trying to explain it and putting it together are two different challenges. You know, clearly I had some help, but I want you to do what I do. And this is when I put this thing together originally long ago. That's why I sometimes stumble. And I have over 1,000 tutorials just in the formulas deal, and not to mention the other 800 combined in my tutorials. So, you know, bear with me, please. I can't remember everything. It's a kind of a scatterbrain approach, but again, take your time, think through the logic, just take it piece by piece, one step at a time, and it's a puzzle. Put the pieces together piece by piece. Brad Williams, XL Prime. Williams out.